Okay, hey everybody. We're gonna go over the real quick the what was it? Yes, the chemistry of ocean acidification section yesterday. I didn't feel like we went over that. I didn't give you guys enough time to start it. So on the left, you kind of see these steps. Like the first step, what happens is that you all know that ocean absorbs a CO2 from the atmosphere. So when that happens here, this black arrow, you're gonna get a series of chemical reactions. So let's start with that first one you see on the right on top, okay? So I'm going to draw it right under here, and it's going to be CO2 plus H2O, and this is water from the ocean. And then what's going to happen is that it's going to create a carbonic acid, and then a hydrogen ion, okay? So that's going to be the first thing that happens. What we want to pay attention to is that this is the key. This is that major key of like this whole process. It's this hydrogen ion, okay? Because this hydrogen ion is what's gonna make the ocean more acidic, okay? And then this HCO3 here, which I'm gonna circle in light blue. This is carbonic acid, okay? So this is carbonic acid. So carbonic acid and hydrogen ions are made from the bonding of H2O and the bonding or reaction of water, which is H2O, and CO2, carbon dioxide, okay? So I'm going to scroll down a little bit more. Actually, let me just erase that arrow first. Okay, so I'm going to scroll down just a little more. And then you have that second reaction right there. And that second step with the H and the carbonate. So let me just draw that for you guys. So what you have here is that you're gonna have that H plus, which is that hydrogen ion, plus the carbonate that's available in the ocean, okay? And that's gonna create more carbonic acid. Yeah. So it's these hydrogen ions again, and this time in the second part of the phase of this reaction, or the second series of reactions, is that they're going to steal the carbonate ions, the available carbon ions, to make more carbonic acid, which is going to make the ocean more acidic as well. Okay, and then next you're going to see this happen, and then because of this reaction with the coral. So let me write this in let's say purple. So it's this reaction in purple that isn't readily, it doesn't happen so often because there's no carbonate available. And this is the chemical reaction here that creates the shells of creatures like sea urchins, not sea urchins, I'm sorry, clams and oysters. Okay, so like all the foods that we rely on, like coastal communities like rely on, like when you're eating like oysters or like lobster or crabs, they don't have this carbonate available to calcify or make their shells. Okay, and then that should be CO3 2 minus. And you're gonna notice here, these are the common similarities between them here in this light green. Everyone wants this carbonate here, okay? Everyone wants this carbonate here. But the problem is that people are gonna, the hydrogen here, you want to think of the hydrogen here, the hydrogen ions that are made from the CO2 being absorbed into the ocean. They're stealing all the carbonate available. Think of it like the beginning of the pandemic, when all the people like started stealing all the toilet paper and hand sanitizer. Well, not stealing, but buying up all the hand sanitizer and the toilet paper. Because I want you to think of those scalpers, basically. Okay, those scalpers are basically the hydrogen ions. They're stealing all the necessary materials that are needed to make those shells. So I'm really hoping this explanation video helps you understand like the video as well, the chemistry behind ocean acidification as well. Okay, I'm running out of time on this screencastify, so I'm hoping this hoping this helps. If you need anything, just email me or and shoot me a question. Okay. All right, I'm signing off. Like, subscribe, share.